So, review of what we did last day. We were talking about space travel. A lot of this is not going to be on your test. Josh, this was me as a nerd going on a bit of a nerd fest. I wanted to let you know some of the probes that NASA has built. So we talked about the Curiosity. I showed you the video of how they actually landed that thing. It was pretty darn impressive. I'm not going to test you on that. That was purely as a little nerd trivia. We talked about the astronauts and the ISS. We saw a video about weird stuff that has happened during space landings. Landing in the bottom of a lake. Yes, having to stay underwater for 8 hours until you're rescued. Yes, landing in the middle of a Russian winter and having to shoot wolves and defend yourself. Yes, weird stuff has happened. Space travel is dangerous. I said to you that we had built 6 space shuttles. 2 of them have blown up. That's a 1 in 3 chance of failure. That's not great. I did say to you that I did take a selfie with a space shuttle, and I suck at selfies, clearly. And we looked at how you go into space. We talked about Chris Hadfield, one of my nerd heroes. Talked about Scott Kelly. We said it was so helpful because he had a twin brother who was also an astronaut. So basically they were running similar diets and similar medical tests, but you had genetically identical twins. So you could have his brother, Mark, I think Mark Kelly was his name, was doing the same medical tests on the ground as Scott Kelly was doing up in outer space. We really have to do a lot of research on the effects of zero gravity on humans. The effects, Josh, are not good. Our heart muscles weaken because they're so used to having to pump against gravity that when you don't have them pump against gravity, they get much weaker. Your bone density goes down. But we're working on it. I think I will ask you on your test a couple of NASA spin-off technologies. How many did I give you? Sorry? 8? I'll probably ask you for like 3 or 4. Because I'm a NASA freak, so I like NASA. We talked about space debris. That's going to be a bit of an issue. We're messing up everything, and we're not just messing up the Earth, we're messing up space too. Seems to be a human condition. We talked a little bit about SpaceX, Blue Amazon. That's not going to be on your, or Blue Origin. That's not going to be on your test. That's just current events right now. And we paused here. What I want to talk about are aliens, life out there, outer space life. So, parts of this will be on your test. Says aliens exploring space and life out there. And we're going to start off with a little question. The question is, why can't my students get to class on time? No, that's, you have to pause. This is not scientific. This is just me wanting your opinion. Do you believe that there is intelligent, speaking, sort of like us, intelligent life beyond Earth out there? We're going to take a vote. Who says, yeah, I think there's aliens, real life out there? 1, 2, okay, 1, 2, 3, 4, 5. Who says, no, I don't think there's aliens out there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Who didn't vote? You've got to know I'm going to track these things and keep track of who doesn't have an opinion. You've got to know that. This is me. So most of you say no. That's interesting. Last year, most of my kids said yeah. I almost wonder if it depends what big movie has come out recently and swayed your opinion one way or what kind of current events have gone on. So we're going to talk about aliens. Not the Donald Trump kind, the life out beyond space kind. We need to talk about something called the Fermi paradox. And this is kind of right now what drives our thinking. The Fermi paradox is named after Enrico Fermi. Enrico Fermi was a famous physicist. In fact, he was the one who helped initiate the first nuclear fission reaction, did it quite casually underneath Chicago Stadium. He was a physicist. But he was also very famous for being able to do a whole bunch of rapid calculations in his head and coming up with a good approximation to an answer. Let me give you an example. At the very first atom bomb test, since he was on the team that developed the first atom bomb, he was a witness to the first atom bomb test. It's called the Trinity test because it was at the Trinity test site. And brilliantly, because they were trying to calculate how big the bomb was, but you can't be close, you're really far away. What he did is he held a piece of paper, and as the shock wave hit them, he let the piece of paper go, and he looked at how far back the piece of paper flew, and from that he was able to tell them pretty accurately how strong the bomb was. And when they actually ran the numbers, he was pretty close. He was very famous for just being able to do a whole bunch of calculations, rough guesses, but getting really close to an answer. What he would do, his habit was, if he was making a guess, he would guess the first number too high, and then he would guess the next number too low, and he would guess the next value too high, and he would guess the next value too low, because he figured all those high and low guesses would balance each other out, and I bet you by the time I'm done, I'll be pretty close. We actually call them Fermi calculations, or Fermi problems. So, he's sitting at lunch one day after the nuclear test. This is in the 1950s. And he and his friends were discussing the possibility of intelligent life in the universe. And the story goes, all of a sudden he sat there, didn't say anything. He's running a bunch of numbers in his head. And all of a sudden he just blurted out a question. 3 words. He blurted out, "Where is everyone?" This is called the Fermi paradox. Get it. Patience. So here is what he had just done in his head. He had looked at the age of the universe, about 13 plus billion years. He had looked at the number of galaxies. He quickly estimated the number of stars in each galaxy, and he'd made a rough guess as to how many intelligent technological civilizations should exist based on random evolution of life. And his rough estimate suggested there should be several thousand. And then he said, even if we don't have fancy space travel, even with our current level of travel, just with several thousand intelligent life species, we should have come across stuff in our galaxy. There's been enough time for our galaxy to be populated the same way humans have spread out over all the Earth. There's been enough time for life to have spread out over all galaxies. We haven't seen any. We haven't seen any. This is the Fermi paradox. Fermi paradox, it's 3 words. Where is everyone? Seems like mathematically enough time has gone by. Seems like mathematically, statistically, there should be intelligent life out there. We don't find any good reason that we're particularly special. Where is everyone? So, this is called the Fermi paradox. On one hand, it seems that there should be many different civilizations out there. On the other hand, we haven't found any. Well, I heard that, no, we haven't found any. We really haven't. What about Area 51, Mr. Duke? We really haven't found any. Put your pencils down. So what about non-intelligent life? Bacteria, microbes? We're looking in our solar system. Curiosity, the rover on Mars, is looking. The other place we'd like to look at is Europa. Europa is a moon. It's one of Jupiter's moons, and it has a massive ocean of water underneath a covering of ice. But underneath that covering of ice, there is liquid water. On Earth, anywhere we found liquid water, we have found microbial life. So we would love to go ice fishing in Europa. Put your pencils down. There's my speculating on alien life. This is what you want to do as your review for the test, those questions from your textbook, and this brings us to the end of astronomy.